Hey everyone, today is Christmas, let's see what is special about today's LeetCode POTD. We are going to solve maximize happiness of selected children. So the problem states that we are given an array happiness of length n and a positive integer k. Now there are n children who are standing in a queue where the ith children has this happiness value of happiness of I. And now we want to select k children from this n childs in k turns. And in a single turn, what we can do is we can select a child and the happiness value of all the children that have not been selected till now will be decreased by 1. Okay, and we are given that happiness value cannot become negative, means it gets discriminated only if it is positive, means the minimum value that will be reaching it will be 0. Okay, now we need to return the maximum sum of the happiness values of the selected children we can achieve by selecting k children. So we are given n children, out of them we need to select k children in k moves, such that means in each step we'll be adding their happiness value and all the remaining child's happiness will be getting decreased by 1. In this fashion we'll keep choosing the children such that we want to maximize the total sum of happiness values. And the sum means constraints can go up to 2e5 and happiness value can go up to 1e8 and this k can go up to n. So let's see like some of the inputs so that the question becomes clear. So we are given 1, 2, 3 and k equals to 2. So obviously in the first move what we'll try to do, we are given the values as 1, 2, 3 happiness values. So if we choose, like if we try to choose this smaller value, then our happiness value will be increased by 1 and the new array will become what? Means new array we have already choose this. So this will become 1 and 2. All the happiness values will be decreased by 2 and we cannot pick this child again. Okay, so we see like means two bigger values have been reduced. And let's try to again see means use this one. So the happiness value will be increased by 1 and the new final array will be simply will not be able to choose these two child and the happiness value of this will become 1. So obviously like picking smaller values will eventually get us lower sum. Okay, so let's try to pick bigger values first. So we are given 1, 2, 3. So if we pick this 3 in the first step, so the happiness value will be increased by 3 and the new array will become will not be able to pick this child. The happiness value will be 1 and here it will be 0. Okay, now simply we'll be able to pick this child, so happiness value will be increased by 1 and in the end after this, since it cannot become negative than 0, so it will still remain 0 only. Okay, so this will be the total happiness value or sum of happiness values, which is 4 and which is the maximum possible. So what is the approach to solve? We simply start from the maximum happiness value and add it to our answer and then means keep track of the number of moves that you have performed, and the number of moves that you have already performed, by that value this value will be getting reduced. So let's see another input. So if we are given k equals to 2 and the input is this 1, 1, 1, 1. So as soon as we pick any of the ones, the happiness value will be increased by 1 and now the new array will become what? We will not be able to pick this child and all other values will become 0. So obviously even if we pick these childs, the happiness value will be increased by 1, increased by 0 only, so we'll be able to only perform a single operation in this case. And hence the maximum sum of happiness values we can get is 1, which is the output here. Let's see another input. We are given 2, 3, 4, 5 and here the k value is only 1. So that means we can only perform a single operation. So we'll be picking this maximum value. So maximum value is 5. So happiness value will be increased by 5. And we know like after that means the configuration does not matter because we have already performed the required number of operations. So in this case, the output here is simply 5. So what do we observe? We simply need to means keep track of the max element so far. Max element. Okay. If we try to iterate from the max element, then we also keep track of the number of moves that we have performed. Okay, moves already performed, which is initially 0. Now, if the current element is this suppose element, then based on the number of moves that we have performed, its real value will be what? Real value will be simply element minus the number of moves that you have performed, because the number of moves that we have performed that many times it will be decreased by 1. Okay, so real value of this particular element that we are currently processing will be element minus moves. So we'll be increasing our happiness value by this value, and again we'll iterate in a means from the max element to the min element. Okay, so that we are getting the maximum sums initially only, so that the overall sum of happiness values increases by a largest factor. So what do we need to do? We can simply sort the given happiness we can simply sort the given happiness in like a reverse, in a decreasing fashion. Okay, so let's sort it in the decreasing fashion, r being into r n. Now what do we want? We'll simply maintain these two values. These two values are what? We'll simply have max, means number of moves that we have performed, number of moves which is 0, and maxi which is the overall result that we'll be having. Okay, now we simply iterate through each element of this happiness. Okay, so we'll be iterating through each element of this happiness. Now what do we want? We want the new real value will be what? Element minus moves. So when, means it should be, means this addition is only visible when this value is greater than moves. Otherwise we'll be adding simply 0. Okay, this value would have become 0. So we'll simply check, like if this element is still greater than the moves, then we can simply update our maxi with the current value that we'll be having, means the current happiness that is remaining, and now we'll simply increase the number of moves by 1. And we also, means we can at most perform k operations, so we can only do this till k is greater than 0, and we know like k is greater than equals to 1, so the first move will be able to perform. Okay, now we have reduced k. Okay, and else if this condition is not satisfied, then we know like all the remaining happiness would have become 0, so we can simply break, because all, means further values will be further smaller, so means checking this is not feasible. And in the end we simply check, like if k has become 0, that means we will not be able to move towards further elements, so we can simply break in this cases. Okay, so this is the simple algorithm that we can use, and in the end we'll simply return maxi. In the end we can simply return this maxi. So this is the simple approach that we'll be using. We'll simply sort it on the basis of maximum element to the minimum element. We'll iterate from the maximum element, and at each step maintain the number of moves that we have already performed, and based on that each element's value will be modified to element minus moves, and if that value is greater than 0, then that will add a positive contribution to our maximum happiness, means sum of happiness, and we'll be accounting that. So this is overall n log n approach for this problem, and let's try to see the implementation also to get a clear understanding. So we'll simply have sort this in reverse fashion. We have the moves, we have the initialize the answer. Now if current element is greater than the move, simply increase our answer, increase number of moves, decrease number of operations. If it is not, means if element is less than move, then all further elements will have become 0 only, so we can simply break. Or if k is equals to 0, we can also break as well, and then we simply return answer. So this is like the n log n approach for this problem, and the space that we have used is constant if we try to avoid the space used for sorting. So this is like the overall, like it was pretty simple. We just simply needed to iterate from the maximum element towards the minimum element, and we are done. So let's try to submit this code as well here and see how much time it takes to run. It should run pretty fine because of the complexity n log n. It runs in 17 ms, but let's try to see what the bigger solutions are and see where. So they are also doing the same, only they are like sorting the happiness in reverse order and doing the same. So this doesn't matter like how much time it is taking, because the algorithm still remains the same of whatever the top solution was. So I hope means you are able to solve it on your own, and if you weren't, then you are able to grasp the logic involved. And if you did, make sure to like as well as subscribe, and if you yet have any doubts remaining, make sure to comment down. I will be happy to respond. Thank you so much for watching.